Hello everyone, this video is brought to you by Gia Online Education. In this video, we will learn about salts, their family, and more about NaCl. So let's start the video. What are salts? Salt is any chemical compound formed from an acid when a proton ion from the acid has been replaced by a metal ion or another positive ion. So in salt, the proton part of the acid is replaced by any other positive ion. Then we get a salt. Or we can also say when acid reacts with base, we get a salt. Salt contains both acidic ion and basic ion. Hence, salt is an ionic molecule which contains cation, which is positively charged ion, and it contains anion, which is negatively charged ion. So, how salts are formed? Salts are formed by the combination of acids and bases. Salts of strong acids and strong bases are neutral, whereas salts of strong acids and weak bases are acidic in nature with a pH value less than 7. Whereas salts of strong base and a weak acid are basic with pH value more than 7. So we have three categories of salts. One neutral, another one acidic, and then third one is basic. Neutral salt contain strong acid and strong base. Acidic salt contain strong acid and a weak base, whereas basic salt contain strong base and a weak acid. Let us take in examples of all these salts. So for acidic salts we have aluminium chloride, zinc sulfate, copper sulfate, ammonium sulfate. Basic salts we have sodium acetate, sodium carbonate. Neutral salts we have sodium chloride, potassium nitrate and sodium sulfate. Among these, the most common and most important is sodium chloride, which is also known as brine. It is very important industrial component and helpful in the preparation of various important products like sodium hydroxides, bleaching powder and many other. So in this chapter we will learn more about NaCl. Let us first study about the family of salt. What is salt family? Salt having common acidic or basic radicals are said to belong to same family. For example, if we talk about sodium chloride and calcium chloride, here sodium chloride NaCl, calcium chloride CaCl2. In both these salts, the anionic part, that is the basic radicals, are common. So here the salt belongs to chloride family since both have same basic chlorine element. Let us take second example, calcium chloride and calcium sulfate. In these two, in calcium chloride, the common ion is calcium. In calcium chloride and calcium sulfate, in both these salts, the common ion is calcium, that is acidic radical. So both these salts belongs to calcium family. Now in third example, zinc chloride and zinc sulfate. Zinc chloride and zinc sulfate both contain zinc as a common metal ion. So both belongs to zinc family. So for naming salt, we need to check the common ion first, whether acidic group is common or basic group is common. So here are some more examples of salts. Potassium sulfate, it belongs to potassium family. Sodium sulfate belongs to sodium family. Calcium belongs to calcium. Calcium sulfate belongs to calcium family. Magnesium sulfate belongs to magnesium. Similarly, all these salts have a specific family written over here. And here we have provided the combination by which these respective salts are formed. For example, potassium sulfate K2SO4 is formed by the combination of H2SO4 and KOH. Similarly, sodium sulfate Na2SO4, it is a salt which is formed by the combination of H2SO4 and NaOH. So this is the slide by which you can take an example of various salts along with their family and their respective parent ions. So to sum up, we can learn that the salts which are formed from strong acids and strong bases are neutral. Salts between strong acid and a weak base are acidic. And salt formed between a weak acid and a strong base are basic. So here are the radicals which are present in all these respective salts. By combining these radicals, we will get a specific type of salt. Now let us study about common salt. What is common salt and why it is so important? Common salt is NaCl. It has a pH of 7. So what does this pH indicate? The pH indicates that the salt is neutral in nature. It is formed by the combination of strong acid and a strong base. It is a white solid obtained in a large scale by evaporation of seawater. It is obtained by the combination of HCl and NaOH. Here HCl is a strong acid and NaOH is a strong base. Hence NaCl is a neutral salt. This is the salt that we use in our food. It is also a raw material for various important materials of daily life. So let us see what are the raw materials. Let us see what are the uses of common salt. Essential constituent of daily life, manufacturing of soap. It is used as a freezing mixture. It is also used as a preservative for meat and pickles. The most important and significant role which NaCl plays is that it is used for the preparation of sodium hydroxide, bleaching powder, baking soda, and washing soda. So these are the chemicals which can be prepared by using common salt. So common salt is a raw material for the preparation of all these materials. So let us study one by one the preparation of these. So in this slide, in this video, we will study the preparation of NaOH first. NaOH is also known as sodium hydroxide. How it is prepared? The process by which NaOH is prepared is known as Chlor Alkali process. This is known as Chlor Alkali because in the preparation of NaOH, chlorine is released, which is released as a byproduct, and it is again an important raw material for various other processes. So the decomposition of brine takes place in presence of electricity to produce NaOH. The overall equation is NaCl, that is aqueous solution of NaCl, that is in presence of water. It forms sodium hydroxide along with the formation of chlorine and hydrogen gas. Chlorine gas is given off at the anode, whereas hydrogen gas is at cathode. Sodium is collected at cathode, where it reacts with water to form NaOH. So in this process, the three products NaOH, chlorine and water, all these three products are very useful. Now let us see how these are produced or how the decomposition of NaCl takes place. So this is the setup which is known as electrolysis of NaCl. Here in presence of electricity, brine, that is NaCl, is taken. Here in this setup you can also see the two electrodes are present. One is anode, another one is cathode. Anode is formed of titanium, whereas cathode is formed of steel. So, in presence of electricity, NaCl decomposes to form sodium metal and chlorine gas. So, chlorine gas is released from the anode. Since chlorine is negatively charged, it is a non-metal, highly electronegative. So, it moves towards the anode and releases from anode side and collected there. Whereas sodium, being a positively charged cation, moves towards the negatively charged electrode, that is towards the cathode. Now here at cathode, sodium reacts with water to form NaOH and releases hydrogen gas. So hydrogen is released at cathode and collected over here. Now the NaOH which is formed after the electrolysis is then taken out from the outlet. So this is the process. Here brine electrolyzes through electricity and forms sodium ion, chlorine gas and hydrogen gas. Sodium ions are converted into NaOH in presence of water. So the overall electrolysis reactions can be summed up as here NaCl decomposes to form Na and Cl first. Na at cathode reacts with water to form NaOH and releases hydrogen gas. So this is the gas which is released. At anode, atomic chlorine combines to form chlorine gas. So chlorine is released from anode, whereas hydrogen is released from cathode because it is prepared there only. The overall reaction can be summed up as NaCl in presence of water forms NaOH plus chlorine plus hydrogen gas. Now let us talk about the products of electrolysis of brine. During the electrolysis of brine, the main product is sodium hydroxide and the byproducts are hydrogen and chlorine gas. These are also very important components. So chlorine is used for water treatment. It is also used as disinfectant. It is also used as a raw material for the preparation of various important polymers like polyvinyl chloride, that is PVC, and CFCs, that is chlorofluorocarbons. Chlorine is also an important byproduct, important raw material for the formation of bleaching powder and pesticides. Now, if we talk about hydrogen gas, another byproduct of electrolysis of NaCl, so it is used as a fuel. We know that hydrogen is a clean fuel. Its combustion releases large amount of energy. Hydrogen is also used for the manufacturing of ammonia. So, the products of electrolysis of brine are also very important and plays a significant role in the preparation of various other important materials. Now, what are the uses of sodium hydroxides? Sodium hydroxide also have various uses. It is used for the manufacturing of soap, detergent, also used as a raw material for fiber industry. Since NaOH is an ionic compound, it is used as an electrolyte. So, electrolyte solutions are used for the electrolysis of various other components and for the ionization process. So, NaOH has a significant role to play in the chemistry. So by this we come to an end of this topic, that is Chlor Alkali process. Hope you all learn many things from this video. Thank you.